Hello everybody, welcome to Group 17's Column Valley Solar Farm Project Management Plan presentation. At SJMN Engineering and Construction, we focus on building renewable projects that communities can stand behind. Our approach is simple. We listen early, plan clearly, and keep our sites safe, clean and efficient. Column Valley Solar Farm really captures our way of working. Honest communication, firm delivery dates and high quality handover. We work closely with local suppliers, maintain strong relationships with neighbours and protect the land, water resources to ensure that asset operates smoothly from day one. Column Valley Solar Farm is a 189 megawatt peak project located in the Riverina region of New South Wales. The site includes 4 inverter pads labelled A through to D and a new 132 kilovolt substation and grid tie. Construction and commissioning will run from January 2025 through to October 2027. Once operational, the solar farm will produce around 385,000 megawatt hours of clean electricity annually, enough to power tens of thousands of homes. The site lies on a flat, low-lying floodplain, which requires detailed drainage design to manage stormwater. Soils here are mainly alluvial silts and clays, so erosion and settlement were key design considerations. Access was another challenge. Heavy vehicle limits on the Kidman Way meant we needed to strengthen and coordinate logistics carefully. We also worked to preserve biodiversity buffers and existing irrigation channels, and we faced some limitations on grid expansion capacity near the Transgrid corridor.
The first part of our risk management plan is the risk identification, where we have divided the risks into different segments of the project, including the design phase, construction phase, and the handover and commissioning phase. Identified design risks include issue with the design due to coordination across various disciplines, and environmental planning and compliance. Construction risks include adverse weather conditions, supply chain disruptions, and labour shortages. Handover and commissioning risks include final product defects and contractual disputes. Our team have developed a risk register in order to quantify the project's most significant risks on a scale of 1 to 25. This compares the likelihood and consequences of these risks alongside our proposed mitigation strategies to best manage these risks.
The program runs 706 days, planning, then pre-construction, then construction. Work streams are enabling works, 4 pads with inverter rooms and substations. Pads are staged and overlapped. Pad D runs the longest and finishes mid-September 2027. We then demobilise and hand over by October 2027. We only start construction after 2 commercial gates. Our 3 crews moving away from Pad A to Pad D, so the finish follows at Pad D. On all pads, earthworks are completed, followed by FRP crews, handed straight on to our solar and install crew. From there, we move to substation testing and energisation. Due to crew rollover, if one pad fails testing, it pushes our completion date back. This is why the chain sits on critical path. Our overheads stay in place for the full 234 days, so the 3 production crews can run without stoppage. Bulk earthworks open the site with fencing, access roads and drainage, so every pad has access. The FRP crews follow with pads, footings and slabs, including inverter rooms and substation foundation using concrete pumps and on-site testing. The solar and install crew then drives mounting, panels and cabling, completing inverter room fit out and finishing string testing. Crews rotate across from Pads A to Pad D in stage patterns so materials and plant are used efficiently and the critical path stays on track throughout to handover. Our construction total is $162 million. That is about 88 cents per watt. The estimate is bottom up against the work breakdown structure with uniform measurement rules for all pads. The largest cost is the construction stage. Pads contribute to about 87% of the total cost, with Pad B the largest at 30% and Pad C nearly at 25%. For materials, roughly 50% of the cost is panels. Mounting and foundations add 25% combined. The substation is just over 9%. And the quarry and backfill are 6%. We include base allowances where scope is not yet fixed. Contingency is 10% for solar and civil and 15% for substation and grid. Overheads and profit are about 12%. If award moves, we will apply the 3 to 4% per year escalation. Including planning construction with labour and materials, project sits at 165 to 167 million.
Starting with WHS, the main site risks include electrical work, heavy machinery movement, manual handling and heat exposure, typical of the Riverina region. To address these, the team applies strict control measures such as exclusion zones, lockout tag-out procedures and hydration policies. Daily pre-start meetings and toolbox talks ensure compliance, with clear responsibilities assigned to the HSE officer, supervisors and all workers under the WHS Act of 2011. From an environmental standpoint, the project follows the Environmental Planning and Assessment Act and AS 14001 standards. The CEMP includes subplans for erosion control, dust, noise, waste, and flora/fauna protection. These are reviewed weekly and after major weather events to ensure compliance. Compared to the original Colin Valley case study, our plan is more structured and proactive, including digital WHS reporting, stronger fatigue management, and rehabilitation measures that reflect current New South Wales renewable energy standards. Given the remote riverina location, the site operates as a self-contained compound with on-site facilities, bore water supply, and controlled access from Kidman Way. At peak, around 80 to 100 personnel work on-site following a 5-day roster. The central compound houses offices, first aid rooms, and storage, with dedicated laydown areas and all-weather access roads are constructed to RMS standards. Key constraints include narrow local roads, high temperatures, and nearby irrigation channels. To manage these, deliveries occur during daylight, early morning shifts are used in summer, and sediment basins control water runoff. Communication across large site is supported by GPS and radios. Stakeholder management is a major focus. Weekly coordinations occur with Energy Australia and Transgrid, and monthly updates with the local council, and regular communication with local landholders. Overall, compared to the original case study, this plan places a stronger emphasis on workforce safety, digital stakeholder tracking, and heat management, creating a more coordinated, compliant, and sustainable site environment.
As part of our monitoring and control plan, our team have developed various KPIs across multiple areas of performance, including cost, schedule, quality, and stakeholders. Each of these have quantifiable targets alongside the monitoring frequency. For quality assurance and control, to minimise rework, the team will apply stringent quality assurance and control measures which include pre-installation inspections of materials to ensure compliance with technical specifications, mandatory sign-offs at key construction stages such as pile installations and module mounting, and root cause analysis of any defects detected during inspections to prevent reoccurrence. Our team's quality control measures include inspection and test plans, non-conformance reporting, and final design verification. Our quality assurance measures include supplier and subcontractor evaluation, process audits, and training verification.
As we move toward project completion, handover is structured around 3 key pillars: commissioning, testing and documentation, and defects liability with training. This ensures the asset meets all operational, safety and compliance standards before formal transfer to the client. Commissioning marks the point where all design, construction and quality assurance work is proven in the field. It includes mechanical, electrical and SCADA testing under Australian Standards 3000 and 4777.2. Stakeholders like Energy Australia, Transgrid, AMO and the Clean Energy Regulator each play a role, from grid compliance and environmental approval to LGC accreditation. Every component is validated through factory acceptance testing, string verification, MPPT monitoring and infrared hotspot inspections. All results are captured in a commissioning dossier that includes test certifications, compliance statements and as-built data. These documents ensure the asset operates safely and efficiently from day one. Finally, we have a 2-year defect liability period managed under ISO 9001 quality systems. Any defects are logged, investigated and resolved under defined SLAs, typically within days. Comprehensive training is also delivered covering SCADA operation, maintenance scheduling and safety compliance under Australian and New Zealand Standard 4836. This guarantees Energy Australia's team is confident and fully capable of managing the solar farm long term. Thanks.